Hello, in this video for MAC2233, Calculus for Business and Social Sciences, we'll be continuing with definite integrals, but we're going to add U substitution into the picture. So let's say we had the integral from 1 to 2 of 2x minus 1 times e to the 2x squared minus 2x dx. Well, it's a more complicated one. I have two things being multiplied. There's an e raised to something that's not just x. So this will be U substitution. So our u in this case is going to be 2x squared minus 2x, because e to the 2x squared minus 2x, I don't know how to take the integral of, but if it was e to the u, the integral of e to the u is e to the u. And when you take the derivative of this, the derivative of u, 2x squared minus 2x, you get 4x minus 2. Again, to get dx by itself, you divide both sides by 4x minus 2. So we have dx equals du over 4x minus 2. But we're going to factor out a 2, which will leave us with 2x minus 1, which will match up nicely with the other 2x minus 1. So when I do the u substitution, I'm going to have 2x minus 1, e to the u, and instead of dx, du over 2 times 2x minus 1. And then the 2x minus 1 and the 2x minus 1 would be divided into 1, which they simplify out. So we'd end up with 1/2 e to the u du. Now, at this point, you have two choices. One, you can convert back to x, so instead of u, plug in 2x squared minus 2x. Or, because with the integrals, we can just change everything into the u format. So right now, we have 1 to 2, and that's in form of x. But if I take 2, plug it in for x, 2 times 2 squared minus 2 times 2, that would give you 4 in terms of u. And if I plug 1 in for x, 2 times 1 squared minus 2 times 2, that would give me 0. So in terms of u, it would be 0 to 4. So I don't have to go back to x as long as I change those limits from 0 to 4 into terms of u, like I did. So we have 1/2 e to the u, 4 to 0, plug in the 4, 1/2 e to the 4, minus 1/2 e to the 0, which will give us 26.799. Now remember, if I did go back to x, and instead of u, put in 2x squared minus 2x, that would be fine. You would plug in the 1 and the 2. Plug in the 2 first, and you'd end up with 4. Plug in the 1 first, you'd end up with 0. So really, either way is fine. But we'll go ahead and check this in the calculator. So we take our calculator, we hit Math 9, and then our function is in parentheses 2x minus 1 close parentheses, then a second ln for e to the x of 2x squared minus 2x, close parenthesis. Remember, if you open a parenthesis, gotta close it, open, close parenthesis, comma x. Now we're doing the original, comma 1, comma 2, close parenthesis. And if we did it correctly, we should get that 26.799. So we can do it and check our work as well. Okay, now we'll do this example. Let's say we have the integral from 2 to 3 of x squared over 3 over x cubed minus 1. So the integral of 2 to 3 of x squared over x cubed minus 1 dx. This will be u substitution as well. We're going to do u as x cubed minus 1 because we have that in the denominator, so that would help us simplify a bit. So all the entire denominator becomes u. And the derivative of that would be, the derivative of u would be 3x squared, which will hopefully help with that x squared here. So we have u equals x cubed minus 1. The derivative of u with respect to x would equal 3x squared. Dx times 3x squared will be dx times 3x squared equals du times 1. So du equals 3x squared times dx. To get rid of times 3x squared, divide by 3x squared, divide by 3x squared. At the end, dx equals du over 3x squared. So that's what I'll be substituting in. So we have x squared over, instead of x cubed minus 1, we put u. And instead of dx, we put du over 3x squared. When we simplify it, x squared divided by x squared is 1, so we're left with 1/3, And instead of u to the 1 in the denominator, we'll move it up, so it'll be u to the negative 1 du. Now, at this point, if you want to go back to x, then you can use 2 to 3. Or if you want to stay in terms of u, then we would change it. But let's take the integral first, either way. So we have the integral of 1/3 u to the negative 1 du. 1/3 stays in front. The integral of u to the negative 1 is ln absolute value of u. Then, if we're going to go everything in terms of u, what we did was we took 2, plugged it in. 2 cubed minus 1 is 7. So 2 is in terms of x, 7 is in terms of u. 3 cubed minus 1 would give us 26. So x is 3, but in terms of u is 27. So if we're going to change the 2 to 3, which is an x, in terms of u, 7 to 26, then we don't have to go back to x. So we have 1/3 ln of 26 minus 1/3 ln absolute value of 7, and that gives us 0.437. Again, at this point, when you had 1/3 natural log absolute value of u, if you want to go back to x, you can. Instead of u, you put x cubed minus 1, and then you'd plug in the 3, and you'd get 26. Plug in the 2, you'd get 7. It'd be the same process. Let's check it in the calculator. Be careful how we type it in. So we hit math 9. The function is x squared divided by parenthesis x raised to the 3, subtraction 1, close parenthesis, comma, x, comma, lower bound 2, comma, upper bound 3, the original, and we should get 0.437, which is what we do. Okay? Now we'll do an application problem. So let's say, where do these numbers come in and what do those numbers really mean? So here's an application problem. Your cell phone company offers you an innovative pricing scheme. When you make a call, the marginal cost, remember marginal cost is derivative of cost, for the tth minute of the call is your cost equals, and this would be the derivative of cost, 20 over t plus $100 per minute. So this is a rate of change, this is the first derivative, this is marginal cost. But you want to know, if you make a cellular call that lasts 60 minutes, how much will it cost you? So, first problem, how do we go from marginal to total cost? We take the integral of 20 over t plus 100 dt, and a 60-minute phone call starts at 0, lower bound, ends at 60. That's where the numbers come from. So we have 20 over t plus 100 dt. Doesn't look very complicated, but still I have 20 divided by t plus 100, so this is going to be a u substitution problem. U is going to be t plus 100. The derivative of u, derivative of t is 1. Derivative of 100 is 0. So we get du equals dt. Then we have the integral of 20 over u du. U to the 1 moves up, becomes u to the negative 1. Still haven't taken the integral. 20 stays in front. The integral of u to the negative 1 is natural log absolute value of u. Then you can either go back to t, so plug in t plus 100 in for u, and then plug in the numbers 0 and 60, or turn the 0 and 60 in terms of u, so plug 0, 0 plus 100 is 100, 60 plus 100 is 160, so we can plug in 100 and 160, remember the top one first, 20 ln absolute value of 160 minus 20 ln absolute value of 100 gives you $9.40 for that call. Now let's see, make sure we practice plugging this in as well. So I'm going to go to the calculator and I'll do 20 ln. Now instead of doing absolute value of 160, the absolute value of 160 is 160. So it makes it a little bit easier. Then we do 20 ln of 100, because the absolute value of 100 is 100. And then we can subtract those numbers, 101.50 minus 92.10. That gives us the $9.40. But again, we can check it from the beginning, from the original problem. We do math 9, 20 divided by parenthesis x plus 100, close parenthesis, comma x, comma the original went from 0, comma 60, close parenthesis, enter $9.40. And this concludes Chapter 6. Thank you.